Hello, students. Today I am going to discuss topic PERT. What is the meaning of PERT? Basically, PERT stands for Project Evaluation and Review Technique. The first step is to determine the critical path, and however, in PERT, duration of activity is not fixed but is a random variable. Now, what is a random variable? Random variable is basically a statistical term. I can explain what is a random variable. Now, say random variable is basically by random variable we mean a real number associated with the outcome of the experiment. Let's take an experiment. For example, take for example toss a coin. Now when you toss a coin, you have two possible outcomes: either head comes or either tail comes. That means the outcomes are either head or tail. Define a function x such that x of h is equal to 1 and x of t is equal to 0. That means capital X is a random variable which assigns real numbers 0 and 1 to the outcomes of the experiment. Therefore, a random variable is basically a function which associates real number to the outcomes of the experiment. Now, one question is there, that what is the domain of the random variable and what is range of the random variable. The domain of the random variable is basically the outcomes linked with the experiment. Outcomes linked with the experiment. And what is range? Range is basically the real number, the set of real numbers. Thus, in brief, random variable is a function which associate real numbers to the outcomes of the experiment. What is the domain of the random variable? Domain of the random variable is basically the set of outcomes linked with the experiment. For example, in this, when I conduct a experiment, that is toss a coin, that the outcomes of the experiment as either head or tail. Therefore, the domain of the this random variable is either head or tail. Now, what is range of the random variable? Range of the random variable is basically the set of real numbers. Like in this case, range of the random variable capital X is set of 0, comma 1. Now, random variable is of two types. It can either take discrete values or it can take continuous values. When we discuss about the PERT, that is project evaluation and review technique, we have a random variable. For an activity, ijth activity, the time duration, basically the time duration Tij is a random variable. Now, probability density function of this random variable, that is Tij, has graph or either the shapes. These are three type of graphs are possible. First is like this, and the second is like this, and the third is like this. Now, what is T node, TM, TP in these graphs? T node is basically optimistic time if execution goes well, and TP is pessimistic time if execution goes badly, and TM is most likely time if execution goes normal. These are three possible graphs in the probability density function of random variable Tij. Basically, PERT follows beta distribution. The If we want to find the expected value and variance of random variable, then we have the following formulas: that expected value of random variable Tij is computed by this formula, that is expected value of random variable Tij is equal to T naught plus 4 times Tm plus Tp upon 6. What is T naught, Tm, Tp? As I earlier explained, T naught is optimistic time, Tm is most likely time, and Tp is pessimistic time. Similarly, we can find the variance of the random variable Tij. The variance of random variable Tij is found with the help of this formula, that is Tp minus T naught upon 6 whole square. Again, Tp is pessimistic time and T naught is optimistic time. Now, as critical path as in critical path method, we found critical path. Here in critical path is found as in CPM by using expected value of Tij. That is duration of activity we can take as expected value of random variable Tij. Therefore, the shortest completion time can be calculated by this formula. That is, we can take uh, uh, summation of random variable Tij over the critical activities. If we take summation of random variable Tij over the critical activities, then we can find the shortest completion time. In similar manner, we can find the expected value of random variable T and variance of random variable T. How we can find the expected value of random variable T? We have this formula, that is expected value of random variable T is found by sum up all the expected value of random variable Tij over the critical activities. And similarly, we can find the variance of random variable T. How we can find the variance of random variable T? So in similar manner, we can take summation of variance of random variable Tij over the critical activities. Now, the random variable z is defined by this formula. That is, the random variable z is given by zi minus expected value of random variable zi upon square root of variance of random variable zi. This random variable z basically follows standard normal distribution with the parameters 0 and 1. Now, we can understand how PERT takes place with the help of following example. Let us consider an example. Say, consider this data. We have given the activities, that is activity 1 to 2, 1 to 3, then 2 to 3, 2 to 4, 2 to 6, 3 to 4, 3 to 5, 4 to 5, 4 to 6, 5 to 6. And corresponding to these activities, optimistic, pessimistic, and most likely times are given. Like corresponding to activity 2, optimistic time is 2 and pessimistic time is 8 and most likely time is 5. And similarly, corresponding to other activities, these are the optimistic time and these are the pessimistic times and these are the most likely time. Now our aim is, what our aim is? Our aim is to find the probability that the earliest occurrence time of event 4 is less than or equal to 3. Our first aim is to find the probability so that the earliest occurrence time of event 4 is less than or equal to 13 days. And next aim is to find the probability that the project is to be completed in 23 days. Well, now we can solve this example with the help of PERT, that is project evaluation and review technique. Now we have given the activities. First, we find the expected time and variance of random variable Tij corresponding to these activities. Now we can find the like first we take the example of activity 1 to 2. Like in case of activity 1 to 2, I have to find expected value of Tij. That means Tij. With this expected value of Tij, we have the formula from which we can find this expected value of random variable Tij. That formula I have earlier discussed. This is the formula T node plus 4 times Tm plus Tp by 6. This is basically T node plus 4 times Tm plus TP by 6. Now check the entries corresponding to activity 1 to 2. We have T node 2 plus 4 times we have TM5 plus TP, we have TP as 8 by 6. This becomes 30 by 6. After calculation, we get earliest expected time as 5. This I have right here. The expected time corresponding to activity 1 to 2 is 5. And similarly, we can find the variance. We have a formula for variance, that is, variance formula is variance of random variable Tij is equal to Tp minus T naught by 6 whole square. Corresponding to activity 1 to 2, we have Tp as 8 and T naught as 2, that is 8 minus 2 upon 6 whole square. After calculation, this we get as 1. Therefore, expected value of random variable Tij corresponding to activity 1 to 2 is 5, and variance of random variable Tij corresponding to activity 1 to 2 is 1. Similarly, like I have explained how to find the expected value of random variable Tij and variance of random variable Tij corresponding to activity 1 to 2. In similar manner, we can find the expected value of random variable Tij and variance of random variable Tij in case of other activities. This I can write here. This is basically given like this. Say in case of activity 1 to 3, expected value is 4 and variance is 1. In case of activity 2 to 3, expected value is 0 and variance is 0. And similarly, now, in case of activity 2 to 4, expected value is 4 and variance is 0.44. In case of activity 2 to 6, expected value is 7.5 and variance is 1.36. And in similar manner, expected value and variance corresponding to other activities are given. Now we can draw the network. Network we can draw with the help of activities, like we have given activity 1 to 2. If I have to draw this, we can draw like this. I can show you how we can draw the network corresponding to these activities. Say, first we have given activity 1 to 2, then this is event 1, this is 2, connect 1 with 2, then we have to connect 1 with 3, then 2 with 3. As duration time is 0 0, therefore this means 2 to 3 activities dummy activities, therefore I can draw this with the help of dotted lines. This is 2 to 3. Now there is 2 to 4. Say this is 2 to 4. So this is 4. This, how can we draw like this, like 2 to 4. This is 4. Then connect 2 with 4. then connect 2 with 6, says this is 6, this is 2 with 6, then connect 3 with 4, this is 3 with 4, then this is 5, connect 3 with 5, then connect 4 with 5, then connect 4 with 6, then connect 5 with 6. This is the how we can draw network with the help of these activities. This I can show here. I can draw network with the help of that activities. After drawing this network, you can find critical paths, as I earlier explained in my videos how to find critical path with the help of earliest start time and latest completion time. First I have calculated earliest start time and then latest completion time. After that, with the help of critical activities, I can I with the help of critical activities, I find critical path. Here, critical path is joined by two lines. Like in activity 1 to 2, there are two lines. Therefore, this is critical path 1 to 2. Then 2 to 3, then 3 to 4, then 4 to 5, then 5 to 6. That means we have the critical path as 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then 5 to 6. This is the basically critical path: 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. This I can find. I find in a similar manner as I earlier explained in my video that how to find critical path with the help of critical path method. Now, after finding critical path, we have to find expected normal duration and variance. How to find expected normal duration and variance? Expected normal duration, like we have activities 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Now corresponding to activity 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, we have expected value of these activities like 1 to 2. uh, I can show here that corresponding to activity 1 to 2, expected value is 5. We can take then activity 2 to 3, expected value is 0. Then activity 3 to 4, expected value is 6.83. Then activity 4 to 5, we have expected value as 5 here. Then activity 5 to 6, we have expected value 4. Add these, take sum of these all the expected values. After taking sum of these expected value, like 5 plus 0, 5, then 5 plus 6.83, it is 11.83. Then 11.83 plus 5, it is 16.83. Then 16.83 plus 4, it is 20.83. This is how we can find expected normal duration, that is 20.83. And in similar manner, we can find variance. How we can find variance? I showed you how we can find variance, like we have critical path 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Corresponding to these activities, like corresponding to activity 1 to 2, variance is 1. Then corresponding to activity 2 to 3, variance is 0. Then corresponding to activity 3 to 4, variance is 1.36. Then corresponding to activity 4 to 5, variance is 1. Then corresponding to activity 5 to 6, variance is 0.44. Take sum of all these variances. This becomes like we take sum of these variances: 1 plus 0, 1. Then 1 plus 1.36, this becomes 2.36. Then 2.36 plus 1, 3.36. Then 3.36 plus zero point 0.44, and we get 3.8. Thus, in this manner, we can find variance of random variable t. After finding these expected normal duration and variance, we have now the events corresponding to critical path method. As critical path method is critical path is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Therefore events are 1, 2, 3, 4, 5, 6, and we have to find expected value and variance corresponding to these events. We can start from 0. Expected value of first event is 0, then expected value of next event is now corresponding to activity 1 to 2, we have expected value as 5. Therefore this becomes 0 plus 5 equal to 5. Then corresponding to activity 2 to 3, expected value is 0. Therefore we get 5 plus 0 as 5. Now corresponding to activity 3 to 4, it is 6.83. Thus, we get 5 plus 6.83 as 11.83. Now, corresponding to activity 4 to 5, it is 5. Thus, we get 11.83 plus 5, that is 16.83. And corresponding to activity 5 to 6, it is 4. Therefore, we get 16.83 plus 4 as 20.83. This is how we get expected value of each event. Similarly, we can find the variance of each event. Like we can start from 0. Now to variance of activity 1 to 2 is 1. 0 plus 1 we get 1. After that, variance of activity 2 to 3 is 0. 1 plus 0 we get 1. Then variance of activity 3 to 4 is 1.36. 1 plus 1.36 we get 2.36. Then variance of activity 4 to 5 is 1. 2.36 plus 1 we get 3.36. Then variance of activity 5 to 6 is 0.44. 3.36 point plus 0.44 we get 3.8. Now our first aim is to find the probability, so that our first aim is here that we have to find the probability that earliest occurrence time of event 4 is less than or equal to 13 days. That means corresponding to this we have to find the probability. Thus we have to find the probability such that event fourth, that is z4, is less than equal to 3. Now we have to find the random variable z is given as zi minus expected value of zi upon square root of variance of random variables zi. Therefore, we subtract expected value of z4 and then divide by square root of variance of z4. This is less than equal to 13 minus expected value of random variable z4 upon square root of variance of z4. This further becomes 13 minus what is the expected value of random variable z4, that is given here, that is 11.83. Thus we take 11.83 here, and the variance, what is variance, that is 2.36. Therefore square root of 2.36. After calculation we get 0.716. 0.7616. We can further write it as probability of z less than equal to 0.77. Say we have to find this. Now we can find the probability from the standard normal distribution table. Here is the standard normal distribution table. We have to find 0.77. Here it is zero point 0.7. Point 0.7 is here. Now we look in this row corresponding to 0.07. Here it is 0.07, and the matching value is 0.77935. Therefore, we can take it as 0.7794. Therefore, this is 0.7794. Thus, probability is probability of fourth event such that the occurrence time, earliest occurrence time is less than or equal to 13 days is 0.7794. Now what is our second aim? Our second aim is to find the probability so that the project is completed in 23 days. Now we focused on second aim. that is we have to find the probability such that project is to be completed in 20 less than or equal to 23 days. That is probability of random variable t less than or equal to 23. We proceed in similar manner, that is t minus expected value of t upon square root of variance of t. 23, I have earlier calculated the expected value of t and variance of t, that I gave it here. That is expected value of t is 20.83 and variance of t is 3.8. Thus, that becomes t minus, that becomes 23 minus 20.83 upon square root of 3.8. After calculation, this we get 1.113. Now we look for 1.11. We look for 1.11. First we look for 1.1 in the standard normal distribution table. 1.1, it is here 1.1. Then we look for in point zero 0.01. Then we look for point zero 0.01. This is basically point zero 0.01. The matching value is 0.8665. Thus we get the probability as 0.8665. This is the probability, so that the project is to be completed in 23 days. We find the probability so that the project is to be completed in 23 days as 0.8665. This is how PERT works. That is how project evaluation and review technique works. You can try some more examples of project evaluation and review techniques. If any query is there, then you can ask me your queries in your next lecture. Thank you so much.